To graph the solution set of this linear inequality, we first must graph each of the linear inequalities of the system. So we start by graphing that first one. And to start that, we graph the bounding line, which in this case is not included in the final solution because we don't have our equal to. But the bounding line of the region is simply 4 minus 2x, y equals 4 minus 2x. To graph that, we need 2 points that are on the graph, and if x is equal to 0, then y is equal to 4. And on the other hand, if y is equal to 0, then x must equal 2. So 2 times 2 is 4, and then 4 minus 4 would be 0. So those are 2 points on the graph, so we can graph that line. 0, 4 is up 1, 2, 3, 4. The y-intercept is at 4. And the x-intercept of this line is at 2. This time it's a dashed line when we draw our line, because we're not including the points on the line as part of our solution region. But we still have to decide which side of that line do we shade. And we answer this question by asking, is the origin shaded? Or you could just see that y is less than means down below, so it's the bottom side that's shaded. But if you don't understand that, you can also do it this way. Y less than 4 minus 2x. Substitute in x equals 0 and y equals 0. See if it's true. The resulting equation, or inequality rather, is that 0 is less than 4, which is true. Yes, 0 is less than 4. Well, that's good news. That means the origin is shaded here. So the shady side of our first line is the lower side here. So we've graphed the first of the 2 linear inequalities, and we have to now graph the second one. So that's what we'll do now, graph this linear inequality on the same graph. Okay, so to do this one, we start by graphing the line. Bounding this region, y equals 3/5 x plus 2. So once again, we'll find 2 points on the graph to graph it. And if x is 0, y is 2, that's the y-intercept. So we know that this line crosses the y-axis right here at 2. Now for a second point, let's let x equal negative 5. Because if x is negative 5, the 5's cancel, and you're left with negative 3. Negative 3 plus 2 is negative 1. So y would equal negative 1 if x equals negative 5. So 1, 2, 3, 4, 5. Here we are at negative 5. And then and then the y-coordinate is negative 1. So we have to go down 1 to about here for our second point on that line. Again, we do not include the points on the line, so we graph this as a dashed line. Now we ask, is the origin shaded? Once again, at this time of this region, y bigger than 3/5 x plus 2. So if now we substitute x 0 and y 0, we get that 0 is less than, 0 is bigger than 0 plus 2, which is false. That's not true. 0 is not bigger than 2. 0 is smaller than 2. So, that's the answer to our question concerning the shading of 0. For this line, 0's on the opposite side of the line, of the solution set region. So the solution set is the above part of this one. We're looking for the overlap of the 2 solution regions. So anyway, that's the solution set for the second of the two linear inequalities. Therefore, our solution set is everything not including the boundary line here, but coming down to the intersection, that everything not including the line here, but down to this boundary, and the region is all the points in between those two boundary lines. The solution to this system of linear inequalities.